Okay guys, another video that goes along with nuclear chemistry. It kind of has to do with radioactive decay and what we call half-life. So basically, before I explain what I've written down here, we talked about radioactive decay in terms of alpha, beta, and gamma radiation. And we talked about what an isotope is and that radioactive isotopes actually decay or break down on their own. What this means is, for example, uranium is the fuel for fission reactions. So uranium is kind of the basis of what we use for a fission reaction to actually occur, right? That whole atomic bomb, splitting a nucleus. So uranium is an element that will undergo radioactive decay on its own. Some isotopes, it takes billions of years to decay. Some isotopes only last a fraction of a second. So it just depends on how stable or unstable your isotope is as to how long it will decay. Sometimes it takes days for one of them to decay. Sometimes it takes, literally, I'm not kidding you, it takes 4 billion, I'm not kidding, 4 billion years for a sample of uranium to decay. So all of the uranium that God gave us is still here, right? We have not exceeded 4 billion years on Earth. So half-life is an explanation of that decay. How much time, in terms of the life, does it take for half of an isotope to decay? So this is basically an amount of time. The half-life is an actual time for half of that sample to go away. For example, okay, I'm going to show you on a different sheet. Let's say that I have a 100-gram sample of a uranium isotope. A 100-gram sample. I found that in the earth. Let me write this in black because that red's not showing up very well. So I have a 100-gram sample. After one half-life, okay, so after one half-life, how much uranium would be left? 50 grams. That's the whole point. Half of it is gone after one half-life. So after one half-life, I'll be left with 50 grams of uranium. Okay? So let's say I want the sample to decay again. If it's going to decay again by half, then after one more half-life, I will be left with 25 grams of uranium. So this is what I'm talking about. A half-life is an amount of time that it takes for half of this sample to go away. After another half-life, half of your sample would be gone. Okay? So this is the basis for how you're going to work out half-life problems. But you got to wrap your head around this, that after one half-life, half of your sample will be gone. Okay? So typically the half-lives of isotopes are known. Alright, for example, look at this example problem. The half-life of cobalt-60, alright, this is your isotope, is 5.27 years. We know the half-life of all the isotopes, right? We don't have them memorized, but they're written in a book because some scientists, nuclear physicists, have no life. So cobalt-60 is 5.27 years. That means every time 5.27 years pass, half of a sample of this isotope will be gone. Okay? So the question is asking you, how many milligrams will remain, be left over, after 52.7 years goes by if I started with 10 milligrams? Okay? So you have 10 milligrams of a sample of this isotope, but it takes 5.27 years for this amount to go down by half. Well, the first thing you have to do is kind of some math right here. It takes 5.27 years for half of it to go away, but this is how much time has passed. So the first thing you have to figure out is what's called the number of half-lives. You figure that out by dividing, right? 52.7 years have gone by, right? Let me put a bigger decimal. But every 5.27 years, the sample would decay by half. So this is going to be the years, or let's say time that's went by, divided by the actual half-life that's given to you. Okay? So 52.7 divided by 5.27, what's that, 10? I have no concept of math. I don't. It's my arch nemesis. I second guess myself. Yes, it's 10. I'll have to check. So 10 half-lives. Oh, it should be a V. 10 half-lives have went by. That means, right, this much time passed, and every 5 or so years, the sample will decay by half. So that means I've calculated how many times my sample decayed by half. My sample had enough time to decay by half 10 times. It's went through 10 half-lives. So now what I have to do is play around with, I know how many times it decayed by half, but how much did I start with? Well, I started with 10 milligrams. So I have to do this. I started with 10 milligrams. After one half-life, how much would I have left? 5. After another half-life, I would have 2.5 left. After another half-life, I would have 1.25. After another half-life, I would have 0.625, right? So this is what you're doing. You have to do this 10 times because you have figured out that this sample went through 10 halves, right? It halved itself by 10 because that's how much time has passed. It's decayed by half 10 times. So you have to go through this process 10 times over 10 half-lives. So with 1, 2, 3, 4, we have to go 6 more times. So basically all you're doing is taking this sample and dividing it by 2, right? It halved itself. So you're dividing it by 2. 10 divided by 2 is 5. 5 divided by 2 is this. Divide by 2, divide by 2. So let's go through another half-life. 0.3125. Let's go through another half-life. I just keep dividing by 2 on my calculator. 0.15625. I go again. 0.078125. Go again. 0.0390. Go again. I'm going to run out of room. 0.0195. So let me see how many times I've halved it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got to go one more time. So one more half-life means I'm left with I hope you can see that, 0.0097. 7, right? So this is what happened. I took my original amount. I was given 10 milligrams of a sample, and I wanted to know after all this time has passed how much of that isotope would be left. Well, I have to calculate how many half-lives went by, and I figured over the span of 52.7 years, every 5 or so years it decays. So I just divided, and I came up with 10. 10 half-lives that went by, which is why I took my original sample, 10 milligrams. Okay, this is the 10 milligrams from the problem. And I decayed it by half 5 different times. And this was my final answer. 0.00977 milligrams will be left after this many years. So it's just kind of like a little puzzle, but you have to figure out by the information it gives you how many half-lives went by and then how much you'll have left over at the end. Okay, and we'll work another example, or I'll send another video with a couple of different examples.